Hello 8th graders. In this IXL support video we're going to be taking a look at assignment Y9 on IXL, which is write a linear equation from a graph. And this is going to build on our skills of what we understand already about the slope-intercept formula, or y equals mx plus b. If I want to write a linear equation, slope-intercept formula is an easy way to write an equation for the line. And all it requires, the name suggests this, all it requires is for you to know the y-intercept, which will be b, and for you to know the slope, which will take the place of m. So before I even this whole assignment, every time they're going to ask you to write equations from graphs. So I'm going to go ahead and place that formula, y equals mx plus b, here in the answer box before I even kind of start to analyze the graph much. And then I always prefer to start with the beginning value, the y-intercept, especially if I have a graph, because on a graph it's pretty easy to pick out the y-intercept. It's just going to be wherever the line crosses with the y-axis. And in this case, we can see right here, I'll draw an arrow to it, that's where the y-intercept for this graph is going to be. And I see it sits right between, exactly in the middle of -2 and -4. And I know in the middle of -2 and -4 is a y-intercept of -3. So the fact that this line crosses through the y-axis at 0 and -3, or it has a y-intercept of -3, tells me half of my equation. Already halfway there. I could say plus a -3, or more simply I could just say subtract 3. It means the same thing as adding a -3. Now the other piece is slope, or the rate of change, and as we've practiced on Y1 in class, you know you need to use 2 points on the line to measure that slope. And I can pick any 2 points. I want to pick 2 points that are easy to read on the graph on the line, but also closer together makes my life easier. So in this case, I'm going to use a purple dot. And I see I could even pick this point right here. We'll go one further. And then I'm going to place a dot right here. When x is 2, y was -1. And I see what happens if we measure how this line moves. It climbs up by 2 units and right by 2 units. So it went up by 2, and it also went to the right by 2. So that tells me my slope, my y change was 2. I rose by 2, went up by 2, and at the same time the x value went right by 2. It also gained 2. And as you see for IXL, and same with more on Khan Academy, they always want everything when we write equations in simplest form. And that means if the slope can be simplified, if it's a ratio that could be simplified, we definitely want to do that. So in this case, our answer is really 1 for slope. This graph is just moving up by 1 and right by 1. Every x is going to bring 1 more y, and that's why we see y equals 1 times x minus 3. If we want to go even one step further, IXL would accept this answer, but I'm going to go ahead and delete the 1 because you may remember from Miss Ogagba and Mr. Neville last year that when we have 1x, we usually just simply put it as x. Anytime we see x, it means there is 1x. Alright, so for our next problem, this is going to follow very much the same pattern in Y9. Every time I want to write an equation for a linear graph, there is a procedure that's straightforward. I use this y equals mx plus b formula, and I find the y-intercept and I find the slope. So in this case, we'll show you here, the graph is now jumping by tens. It's a little more complicated. It's going to give us larger numbers, but since both the x and the y-axis jump by tens, it does make our life pretty easy still. I'm going to first mark up the y-intercept. We see this line crosses with the y-axis right there at the -40. And that tells me that my y-intercept is a -40. I'm just going to write that as a subtract 40. You could also put add a -40 if you wanted. And I see, again, here this line is just climbing up by 1 and right by 1. We actually see, we'll switch over to purple for a second, but we see that this line follows that the simplest slope pattern maybe, of just climbing up by 1 and right by 1, and it continues that pattern. So again, our slope is 1 here, and we're going to jump to the next level. We can work through this one. Now it's getting a little more difficult. At least the slope is not 1 over 1 this time. And this one has some cool challenges as well. Sometimes you will see simple linear graphs that start at the origin. You call those proportional graphs last year. They're the simplest kind of linear graph, and this right here is a proportional graph. I call it that because it's a straight line, but it also passes through the origin. The y-intercept is just going to be a value of 0. And as we talked about in some other videos already on IXL, whenever I add 0 for the y-intercept, I don't even need to write the plus b. So the proportional graphs, since the y-intercept is 0, all they require is for you to know the slope. And the slope will multiply with x, and that's how you always find y. It's much simpler if it starts at the origin. And in this case, we can measure the slope. We see it starts at the origin, we'll put one dot there. We see another point up here, and it's climbing up by 2 and right by 1. Now technically, you see this jumps by hundreds on this graph. So if I'm being really exact as a math student, I would say this climbed up by 200 units, because each space going on the y is worth 100. And I would also say that it climbed to the right, or that the x increased by 100 units, because each space right counts for 100, just like each space up counted for 100 on this graph. But at the end of the day, if I go do 200 divided by 100, I'm going to get the same thing as if I had just said, hey, the graph was going up by 2 and right by 1. Our slope here is just going to be 2 over 1. At this point, we think you are certainly in very, very good shape to be doing this IXL Y9 assignment on your own. Would recommend you stop this video, work through IXL on your own. I'm going to skip ahead, and I'm going to go show us towards the back end of the video if students are struggling with some of the tougher problems. I'm going to try to go find a few ones that are closer to the challenge zone. Okay, so here's the first one that I'm going to show us that's a little bit more difficult. The process, the procedure is going to remain the same anytime you have a graph and you want to get the equation for that line. If it's a linear graph and you want the equation, start with y equals mx plus b. Here we see what's simple, what's straightforward. It's actually a proportional graph. It goes through the origin, so the y-intercept is 0. And we can just go ahead and delete the whole plus b part if it's 0. More challenging is if I zoom in on this graph, you'll see that it's kind of challenging to find good data points. This looks like it might have been okay, but now as we zoom in, we see it's like 12 or 13. We're not really sure. So if I'm picking data points, the origin is fine, but I don't see a good data point again until right here. So now I'll zoom back out. I use pinch to zoom there, just using 2 fingers on my trackpad to zoom in or zoom out. And now I'll go ahead and mark those points that I could more easily see. We knew it went through the origin, and we saw that point when x was 30 and y was 40. So now I can more easily measure the slope. I see that it's climbing up by 4 and right by 3. We see that it climbs up by 4 and right by 3, so we'll just label that. That's how we came up with the slope here. Now again, this graph is counting by tens. Technically that would be 40 over 30, but we know if the x and the y-axis have the same intervals, they're jumping by the same set. In this case, they both jump up by tens. Then when we simplify or factor out that factor of 10, we'll just get the 4 over 3 that we had previously seen for the movement. So that gives us 4 over 3 for the slope. And again, the y-intercept was 0, so we don't need to place that there. We're going to move into the challenge zone and see if anything by 90 is a little more difficult, but again, it's going to be the same process all the time. And here we see it's actually pretty straightforward. The slopes may be a little more complicated to read at the end, but we see our y-intercept is just -2, so I'm going to go ahead and replace that. And then you may want to pause this, measure slope on your own, but you can see it climbs up by 1 and right by 2. We'll go ahead and show that in the purple color, up by 1 and right by 2. And that tells me my slope was a positive 1/2. That reminds us we didn't see any negative slopes so far. You would think that they would have given us one. And I'm just going to poke through a few here to see. It looks like they give us positive slopes the whole time on IXL, which is a little bit weird. But, oh, occasionally they do give us a negative slope. Here's an example of one line, the last thing I want to show. Your slopes won't always be positive. This line is moving down to the right. So all that really means is when I have my formula, mx plus b, I'm thinking in my brain, before I even measure the exact slope, I know m is going to be something that's negative, as y is losing value over time on this graph. I can see the y-intercept is the -9, so I'm going to plug that in right now. That y-intercept was -9 here. And our slope this time, we'll go back to the purple color, we see that it's going, if I pick this point out right here, another point right here, we see that this line is moving down by 1 unit and right by 4. So our slope is going to be -1 over 4. Again, double checking, making sure, yep, my line's down to the right, I should have a negative slope. And IXL should have given you more problems with negative slopes because that'll start to come up a lot more, but we might see that on Khan Academy. Thank you for watching to the end of the video. Thank you for the great work on Y9.